All right, so we just finished a little bit of lab time on loops. I'm going to record this just so that people at home can kind of see, starting at the simplest kind of loops, kind of building up a little bit, how you can do some useful stuff with it. So our lab time had us do 4 things that all kind of build on top of each other. Print the numbers from 1 to 10. So for this one, you could use the standard for n equals 0 approach. You could, if I have a specific number range that I'm heading between, then it's not a matter of the loop executing blah times. It's more like start at this number, go to this number. Like if I was going to print the numbers from like 100 to 150, I just say front I equals 100, I is less than or equal to 150, I plus plus. So in this case, I'd just do front I equals 1, I is less than or equal to 10, I plus plus, see out. I, inline, why not? So this will print the numbers from 1 to 10, that. If we want to print the sum of the numbers, this one will build up on top of it. So we have the sum like that. And we'll say sum plus equals I. A lot of people put 1 here, which is incorrect. Some put L, which there isn't even an L. See out sum. And this number should be 55, if you do it right. If I compile the right code this time, there we go, 55. All right, so the numbers from 1 to 10 added up is 55, as we all know. Next up, we need to, so we've done number 1, we've done number 2. Next up, we need to add up all the numbers typed in by the user and print the sum. So now we can't use a for loop, right? Because we don't know how many times they're going to type in a number. So we need to switch over to a while loop. I like while true. Some people use like while cn into x or something like that. I like while true. It's just simple and whatever. Let's do this. And we'll use the read library for this. We'll say int temp equals read. Please enter a number. And we can even make this a const if you want to feel fancy. And that's it. So 1, 2, 3, 1, 2, 34 is, aha, we didn't break, right? If you have an infinite loop, you always need a break. If temp double equals 0, break. Always test your code. I noticed a lot of people had code in there that I know you didn't run it before you posted it on the chat channel because it's not right. So if we go 1, 2, 3, 4, to 0, we get 10. If we go 1 to 100, we get 103. Looking good, looking good. And then the last one is average, okay? So count equals 0 here. Every time we input a number successfully, we're going to increment the count, and then we're going to output sum divided by count. Now, we need to do the floating point average, not the integer average. Right now, if we did like 10 divided by 3, we're going to get 3, not 3.33. We want it to be a decimal. So easiest way of doing this is just to accumulate into the sum. After all, the sum might easily overflow anyway, but if we do 10, 20, 30, you'll see we get 20. That's the average. We do 10, 10, 10, 20, then we get 12.5. Okay. So the easiest way of doing this is just to have a double here. Anytime you do math, one of the rules in C++ is anytime you do math between 2 different types, you're like, okay, are we going to do integer division or double division? The answer is double because the rule is you widen to whichever type is wider than the other one. So if you have a short and an int, a short plus an int is an int. A char, which is technically an integer, char is technically an integer. You're like, wait, I thought these held letters. They do. Letters are actually a 8-bit integer, or technically a 7-bit integer, if you're using ASCII. So this code would work all the way up to count being over 127, because chars range from negative 128 to positive 127. So if you mix a char and a double, you get a double. Okay. If you use a float, you'll get a double, because doubles are wider than floats. Floats are single precision. Doubles are double precision. In fact, doubles are about as wide as you can get in the standard types as these things go. If you have an int and like a long, an int divided by a long long, or long long divided by an int, as we have here. It's going to give you a long long. A long long is a 64-bit integer. If you have a unsigned integer 64, an unsigned standard int. There we go. If you want a unsigned 64-bit integer, then and you mix that with an integer, then you get a unsigned 64-bit integer because it's wider. It's got more bits. It's got 64 bits instead of 32 bits. So the only weird rule is if you mix a unsigned int and a signed int, it widens to an unsigned integer, which oftentimes gives wrong answers. These are no longer. So if you have like -1, so if you like add together -1 and 0, you would think I'm going to get -1. -1 plus 0 is 4.2 billion and change. Why? Because somebody back in the 1970s made a decision that if you add an int and an unsigned int together, you get an unsigned integer, which is almost never what you want. It's almost never the right answer. And we're stuck with it today, 50 years later. So, yeah, that's the one thing you need to watch out for there. Anyway, so like I said, if you just make this a double and that's an int, then this will do double division, easy. Some other people did it like this. So you can cast, which means you're going to change the type. So you can change the type of the integer sum to a double there. And now you've got a double and a int doing math together. And so the result of this will be a double. That's another way you can do it. Another way you can do it is a C-style cast. That'll also convert sum to a double. The proper way, the most proper way, and it honestly doesn't make much of a difference. But don't tell C++ people that. The most verbose and proper way of converting an integer to a double is like that, using static_cast. Static cast to a double. That's the correct way of doing it. Is there actually any practical difference? No, not really. For me, I don't like typing. There's some argument to be made for this. Like you can see, I am deliberately trying to cast it to a double. Yeah, you know what though? Like that also tells me I'm trying to cast it to a double. And like maybe if you're like Control F searching for things, you can search for all static casts or something. Whereas if you search for doubles, you're gonna find a lot of doubles too. But I've never found those arguments especially persuasive. It's never really been an issue for me. But if you want to be proper, if you want to impress people, if you don't want people on Reddit to yell at you for using an improper cast, then wear out your keyboard and do that. That's the most correct way of doing it. And that is our lecture for today. So you guys have the rest of time today to work on your Water E assignment, which is due on 2 days. Don't wait till the last minute. Get it done now. If you guys get stuck while there's somebody available to get you unstuck. And that's it for today. Peace.